TWHN wire is not a recognized standard wire type. The specification likely contains a typographical error, and the intended wire type is probably THWN. THWN, which stands for thermoplastic high water resistant nylon coated, is a common type of thermoplastic insulation used for electrical conductors. It is widely employed in residential, commercial, and industrial electrical wiring applications. THWN wire possesses several key characteristics that make it suitable for a variety of installations. Firstly, it is insulated with a thermoplastic material, typically polyvinyl chloride, commonly referred to as polyvinyl chloride. This thermoplastic insulation provides electrical isolation, preventing short circuits and ensuring the safe flow of electricity through the conductor. Secondly, THWN wire is designed to be highly water resistant, indicated by the W in its designation. This water resistance makes it suitable for use in wet locations such as underground conduits, damp basements, and outdoor installations where the wire may be exposed to moisture. Thirdly, the HN in THWN stands for high nylon. The nylon jacket provides additional protection to the insulation, making it resistant to abrasion, oil, and other environmental factors. This nylon coating enhances the wire's durability and prolongs its service life, particularly in demanding applications. THWN wire is available in a range of sizes typically expressed in American wire gauge, (AWK). The appropriate wire size for a given application depends on the current carrying capacity required and the applicable electrical codes. The National Electrical Code (NEC) provides guidelines for selecting the correct wire size based on the ampacity of the circuit and the temperature rating of the wire. When working with THWN wire, it is essential to adhere to all applicable electrical codes and safety regulations. Proper installation practices, including the use of approved connectors and fittings, are crucial to ensure a safe and reliable electrical system. Improperly installed wiring can pose significant hazards, including electrical shocks, fires, and equipment damage. Always de-energize the circuit before working on any electrical wiring. Verify the circuit is de-energized with a reliable voltage tester. Wear appropriate personal protective equipment, including safety glasses and insulated gloves. Use only approved tools and equipment that are in good working condition. Carefully inspect the THWN wire for any signs of damage such as cuts, abrasions, or deterioration of the insulation. Do not use damaged wire, as it can compromise the safety and reliability of the electrical system. When installing THWN wire in conduits, use appropriate lubricants to reduce friction and prevent damage to the insulation. Avoid overbending the wire, as this can weaken the conductor and insulation. Make sure all connections are tight and secure. Loose connections can cause excessive heat buildup, leading to insulation damage and potential fire hazards. Properly support the THWN wire to prevent it from sagging or being subjected to excessive strain. Use cable ties, straps, or other approved methods to secure the wire to supporting structures. Clearly label all circuits and wiring to facilitate future maintenance and troubleshooting. Use permanent markers or labels that are resistant to fading and moisture. After completing the wiring installation, thoroughly inspect the work to ensure that it meets all applicable codes and standards. Test the circuit for proper operation and verify that there are no ground faults or short circuits. Document the wiring installation, including the wire sizes, circuit configurations, and locations of all components. Keep this documentation in a safe and accessible place for future reference. If you are unsure about any aspect of the wiring installation, consult with a qualified electrician. Electrical work can be dangerous, and it is always best to err on the side of caution. In summary, while TWHN wire is likely a typo and does not exist as a standard wire type, THWN wire is a widely used and versatile thermoplastic insulation that is suitable for a variety of electrical wiring applications. It is essential to select the correct wire size, follow proper installation practices, and adhere to all applicable electrical codes and safety regulations to ensure a safe and reliable electrical system. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring. Remember to consider the specific application and environmental conditions when selecting THWN wire. For example, if the wire will be exposed to extremely high temperatures, a higher temperature rated wire may be required. Similarly, if the wire will be exposed to corrosive chemicals, a chemical-resistant wire may be necessary. The National Electrical Code, NEC, provides detailed information on the types of wires that are suitable for different applications and environmental conditions. Refer to the NEC for specific requirements and guidelines. THWN wire is commonly used in branch circuits, which are the circuits that supply power to individual outlets, lighting fixtures, and appliances. It is also used in feeder circuits, which are the circuits that supply power to branch circuit panels. The ampacity of THWN wire depends on the wire size and the temperature rating of the insulation. The NEC provides tables that list the ampacity of different wire sizes at various temperature ratings. It is important to select a wire size that has an ampacity that is sufficient to carry the load of the circuit. Overloading a wire can cause it to overheat, which can lead to insulation damage and potential fire hazards. THWN wire is typically available in solid and stranded conductors. Solid conductors are generally used for smaller wire sizes, while stranded conductors are used for larger wire sizes. Stranded conductors are more flexible than solid conductors, making them easier to work with in some applications. However, solid conductors are generally less expensive than stranded conductors. The choice between solid and stranded conductors depends on the specific application and the installer's preference. When connecting THWN wire to devices, use only approved connectors and fittings. These connectors and fittings are designed to provide a secure and reliable electrical connection. Do not use undersized or damaged connectors, as they can cause excessive heat buildup and potential fire hazards. When making connections, strip the insulation from the THWN wire carefully using a wire stripper. Avoid nicking or damaging the conductor, as this can weaken the wire and reduce its ampacity. Tightly twist the exposed conductor strands together before inserting them into the connector. This will ensure good electrical connection and prevent the strands from fraying. Properly tighten the connector screws to the manufacturer's recommended torque. Over-tightening the screws can damage the connector, while under-tightening them can result in a loose connection. After making the connections, inspect them carefully to ensure that they are tight and secure. There should be no exposed conductors or loose strands of wire. If you find any problems, correct them immediately. THWN wire is a versatile and reliable wiring material that can be used in a wide range of electrical applications. However, it is important to select the correct wire size, follow proper installation practices, and adhere to all applicable electrical codes and safety regulations to ensure a safe and reliable electrical system. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring. And remember, when you see TWHN specified, it is highly probable that it is a typographical error, and you should confirm that THWN is indeed the intended wire type. This confirmation can prevent delays and ensure that the correct materials are used for the project. Always check the specifications carefully and consult with the project engineer or designer if you have any doubts. This proactive approach will help to ensure the success and safety of the electrical installation. Finally, always remember that working with electricity can be dangerous. If you are not comfortable working with electricity, or if you are unsure about any aspect of the wiring installation, consult with a qualified electrician. Your safety and the safety of others should always be your top priority. Proper grounding is crucial for electrical safety. THWN wire, when used as a grounding conductor, helps to provide a path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock. Ensure that all metal enclosures and equipment are properly grounded according to the NEC. Use screen-insulated THWN wire for grounding conductors to easily identify them. Properly sized grounding conductors are essential for effective fault current protection. Inspect grounding connections regularly to ensure that they are tight and free from corrosion. Replace any corroded or damaged grounding conductors immediately. Surge protection devices, or SPDs, can help to protect electrical equipment from voltage surges caused by lightning or other transient events. Install SPD at the service entrance and downstream panels to provide comprehensive surge protection. Choose SPD that are rated for the appropriate voltage and current levels. Regularly inspect SPD to ensure that they are functioning properly. Replace any SPD that have been damaged or have reached the end of their service life. Consider using arc fault circuit interrupters, or SIs, to protect against arc faults, which can cause electrical fires. SIs are designed to detect arc faults and trip the circuit breaker, preventing the arc fault from escalating into a fire. Install SIs in branch circuits that serve bedrooms, living rooms, and other areas where arc faults are more likely to occur. Test SIs regularly to ensure that they are functioning properly. Replace any SIs that are not functioning properly. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can cause electrical shock. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. Test GFCIs regularly to ensure that they are functioning properly. Replace any GFCIs that are not functioning properly. Regular electrical inspections can help to identify potential problems before they become serious hazards. Schedule regular electrical inspections by a qualified electrician. The electrician will inspect the wiring, grounding system, surge protection devices of SIs, GFCIs, and other electrical components to ensure that they are in good working condition. The electrician will also provide recommendations for improving the safety and reliability of the electrical system. Proper maintenance of the electrical system is essential for safety and reliability. Keep electrical panels clean and free from obstructions. Replace any damaged or worn out electrical components immediately. Repair any electrical problems as soon as they are discovered. Educate yourself and others about electrical safety. Learn how to recognize potential electrical hazards. Know what to do in the event of an electrical emergency. Teach children about electrical safety and keep them away from electrical hazards. By following these safety tips, you can help to prevent electrical accidents and injuries. Always remember that electrical safety is everyone's responsibility. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice from a qualified electrician. Always consult with a qualified electrician before performing any electrical work.